What we're going to do today is sort of explore another way to justify when triangles are congruent. So we looked at side angle in before the last quiz, and we saw that it was possible to construct non-congruent triangles when you were given congruent components. So they gave us this pink angle down here, they gave us one pair of congruent sides, they gave us a second pair of congruent sides, and it was possible for us to get different triangles with that information. So that meant side angle did not justify triangles to be congruent. So that's why we weren't allowed to use that in our proofs. But there is a special instance when side angle does work, and that is when the angle given happens to be 90 degrees. We will be able to justify triangles congruent with that information. What we'll look at today is what it takes to prove triangles are congruent when you have side angle and what that special instance is. So the theorem, as you're about to see, is the hypotenuse leg congruence theorem. So this says that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the triangles are congruent. So if you take a look at this picture, this example, we have a pair of right angles, we have a pair of congruent hypotenuses, and we have a pair of corresponding legs that are also congruent, the legs being one of the other two sides that form the right angle. So with this information, we actually are able to use side angle, but we don't call it side angle. We call it HL. Why does it work? Let's think about Pythagorean theorem for a minute. So if you have a pair of right triangles, we have these right angles, we have corresponding hypotenuses that are congruent, they're both called C, and we have corresponding legs that are congruent, in this case, they're both called A. Well, if we think about Pythagorean theorem, a squared plus b squared equals c squared, there's only one value for b to plug in here to matching a and c. Both of these have the same a and c values, so there's only one value for b that you could possibly have in order to make this equation work, and it's got to be the same number both times. If that's true, then we have a third side congruent, b and b. If all three pairs of corresponding sides are congruent, then side angle would justify the triangle's congruent. Instead of going through that whole process and forcing side angle to work, forcing side to work, we can use HL instead because we know that information will get us congruent triangles 100% of the time. So we're allowed to use that now. And what we're going to do is explore a proof where we actually can use that. I'm going to zoom out for a minute. So you guys can see everything that's happening here. We're going to go through an example. We have our statements and our evidence, and this is the actual proof. We're given that angle P and R are right angles, PS is congruent to QR, and we need to justify that these two triangles, PQS, RSQ, are congruent. So we start with the givens. We know angle P and angle R are right angles. That's given. If these are right angles, now this is going to be where we get a little bit different from what we're used to. If we have right angles, we no longer care about P and R being congruent. That's not the issue. What we have to do is say that since these are right angles, what we actually have are right triangles now. Because this is what matters more, that triangle PQS and triangle RSQ are right triangles. Right angles equal right triangles. If you have a right angle, there must be a right triangle. So we don't care anymore about having congruent right angles. We care about having right triangles, because right triangles mean we can use Pythagorean theorem, means we can have a hypotenuse that's congruent. We're told PS and QR are congruent. That's another given. And those two, scroll back up, PS and QR act as the congruent legs in this case. We can use the reflexive property here, SQ congruent to SQ. And with that information, we have congruent hypotenuses, congruent corresponding legs, right triangles. Now we're allowed to say triangle PQS is congruent to RSQ, and HL will justify that. So this is slightly different from the proofs that you're used to, because we don't care that triangle PQS and RSQ have right angles. We care more that they are right triangles.